When any kind of sound reinforcement system is used, there are two paths that the voice follows in order to reach the ears of the listener. The first is the direct acoustic path. This is the sound of the actor's voice coming from the actor's mouth straight to the audience ears. The second path for voice is an electronic path. This is the sound of the actor's voice entering a microphone and then going to the mixer board, speakers, and then to the audience ears. The sound is coming both acoustically from the actor on the stage and also electrically through the speakers in the auditorium. Audience members hear the sound from both locations and can become confused as to where the sound is coming from. When someone says, "Gee, the voices sound amplified," one of the things they're referring to is that the sound is coming from two locations at the same time. In smaller theater houses, it's important that the sound that is coming acoustically from the actor on the stage be just slightly louder than the sound coming from the reinforcement system. This helps localize the sound on the stage so audience members can easily identify who is speaking and where they are on the stage. Each actor wears a transmitter on a body pack. The microphone picks up sound waves from the actor's voice and converts them to electrical signals. The transmitter converts those electrical signals from the microphone to radio signals, which are broadcast offstage to the receiver. The receiver converts the radio signals back to electrical signals and routes them to the mixer console. From the mixer console, the composite audio signal from all sources is routed to amplifiers and then to the speakers, which convert the electrical signals back into sound waves. A separate transmitter-receiver pair is required for each actor. Transmitters and receivers are set to operate at specific frequencies. Each transmitter and matching receiver must operate on the same frequency in order to convey the actor's voice to the audience. The mixer console must have adequate channels for the number of microphones being used. If you have 10 actors using wireless microphones, you'll need a mixer console with 10 inputs for the wireless systems, plus several more for any other sound sources you may need, such as a CD player. Wireless microphone systems operate in the VHF, or very high frequency band, and in the UHF, or ultra high frequency band. VHF systems are less expensive than UHF systems, presently costing between $300 and $600 per transmitter-receiver pair. Compared to UHF systems, they are easy on batteries. You can expect a VHF transmitter battery to last for about 10 hours. Unfortunately, the VHF band is getting crowded, and in larger cities you will have difficulty with interference from taxicabs, fire and police radio, and other mobile communication systems. UHF systems are more expensive than VHF systems, presently costing between $600 and $3,000 per transmitter-receiver pair. UHF signals do not propagate as effectively as VHF. This is a disadvantage for battery life, since UHF systems must use more power to transmit the same distance. Therefore, you can expect a UHF transmitter battery to last only about 5 hours. On the plus side, the UHF band is much larger, less crowded, and the signals from other transmitters are less likely to interfere with your system. This section of the sound module concerns the two types of microphones most often used in theater: lavalier mics and head-mount theatrical wig mics. Lavalier microphones are usually mounted on the chest area of the actor. These are the kind of microphones you would see on the nightly network news broadcasts, usually mounted on the lapel of a sport coat or on the blouse of an actress. They come in two kinds: omnidirectional, which means that they pick up sound from all directions, and unidirectional, uni being the Latin word for one, which means that it only picks up from one direction. Head-mount theatrical mics also come in omnidirectional and unidirectional styles. They're meant to be mounted in the hair and are therefore quite small. They can also come in colors or be painted in colors in order to match actors' hair. There are three advantages to using a lavalier microphone. The first advantage is ease of dressing. You simply clip it on a piece of clothing. However, as shown in this photograph, that's kind of a mixed blessing. A lavalier microphone was meant to be clipped to a lapel or to a piece of buttoned clothing. This photograph shows a lavalier being clipped to a t-shirt, and as you can see, the cable is not easy to hide without cutting the cloth, and the horizontal clip that the microphone capsule is attached to is at the wrong angle to clip to the clothing and position the capsule correctly. So remember these points when you're clipping on a lavalier microphone. They are easy to clip on, but only on certain kinds of clothing. The second advantage to lavalier microphones is that most actors and actresses are familiar with them and they can dress themselves. The third advantage is that they're relatively inexpensive. The microphone capsules typically cost between $80 and $120. One of the major advantages to using head-mount wig mics as opposed to lavalier mics is that the head-mount wig mic is always on mic with the actor. For instance, since I'm wearing a chest-mounted lavalier microphone, as soon as I turn my head to stage left, the sound quality changes as opposed to looking straight ahead. Same thing happens when I'm looking stage right. And if the actor has to move his head from stage right straight across the microphone and out the other side, the sound quality is continually changing and there's nothing that the sound operator can do to compensate. Most manufacturers have suggestions for the use of lavalier microphones. Number 1. Secure the microphone and the cable secure against clothing so that it doesn't rustle. Second, be gentle when dressing the microphone. Make sure not to shock the microphone by dropping it on the floor or hitting it against a hard surface. There is a major advantage to using a head-mount theatrical wig mic. Theatrical wig mics give you a consistent sound quality because when the actor's head moves, the microphone moves with it. There's always a consistent distance between the microphone and the actor's mouth. One of the questions you need to discuss early in the production process is which of your main characters who are going to wear wireless microphones have to wear hats. Wide-brimmed, stiff-brimmed hats have acoustic characteristics that interfere with the pickup pattern of the microphone. As soon as I put this hat on, the microphone sounds different. And if I have to take the hat on and off in the course of a scene, I run into mechanical problems of hitting the microphone against the hat band. Worse than that, if I don't position the hat correctly, I cover up the microphone and all my succeeding lines come out all muffled. Watch out for the mechanical noise. Howdy, ma'am. Watch out for the positioning. Pleasant day, isn't it? If all of these things are talked about early in the production process, you can Manufacturers have a number of suggestions for improving the efficiency and use of wireless microphone transmitters. First, make the transmitter secure. You want to protect the actor and you want to protect the equipment. Make sure that the transmitter does not move against the actor's body, especially when they might be doing dance steps or other acrobatic moves on stage. The second suggestion is make it waterproof. All actors work very hard when they're on stage, and if they're singing and dancing, they have a tendency to sweat a lot. A wireless microphone transmitter can cease functioning if the liquid from the actor's perspiration gets inside the case and shorts out some of the components. Your best insurance against this kind of failure is to protect the wireless transmitter with a condom. Non-lubricated condoms are excellent insurance against failure caused by perspiration. The next suggestion is make sure that the cable going from the microphone to the transmitter is as straight as possible. This is for two reasons. First, the cable often acts as an antenna. If the cable is kinked or wound up very tightly, the antenna doesn't work as well. Also, if the cable is nice and straight, it's easier on the cable and the microphone equipment will last longer. Here are a number of suggestions to improve the effectiveness of your wireless receivers. First, keep the receivers close to the stage. Typically, receivers are mounted just offstage in the wings. The shortest distance between the transmitter and the receiver is always the best distance. Second, place the receiver 4 feet above the stage deck. This keeps it away from any electrical wiring that might be running underneath the stage and helps to reduce any interference with the radio signal. Next, keep the receiver away from large metal objects. Metal objects can act like shields, reducing the strength of the received signal. They can also act like reflectors, adding interference via multiple signal paths. Try to keep the receiver in line of sight of the transmitter. And finally, keep the antenna of the receiver co-aligned with the antenna on the transmitter. This means that when the antenna on the transmitter is mounted vertically, try to keep the antenna on the receiver mounted vertically also. Likewise, when the antenna on the transmitter is mounted horizontally, the antenna on the receiver should also be horizontal.